Namaste, all of you. Welcome to our session on programming Quran with Python. This will be our fourth session, which we are going to conduct on the topic summation of set of numbers. Up till now, we started with the introduction. We have some exchange of variables, and then we have the counting, where we counted the numbers one by one. The fourth step, which we are going to conduct today, is a summation, which is also an important part when you study about the addition of numbers, which may comes one by one from the user or from the list or from the set. So let us develop this algorithm as per our knowledge, as per our algorithm development method, which we have discussed in our first introductory part. So let us see what is the problem statement. So the given set of n numbers, design an algorithm that add these numbers and return the resultant sum. Assume that n is greater than or equal to 0. So looking at the last line, n, which is we are counting as numbers which are present, a count which can be a 0 or more. That means I can have no numbers to count. So obviously the sum should be 0, or if it is more than that, the summation should happen. The thing is, we have to design the algorithm for n numbers. So obviously the iteration part, the loop part will come into picture, just like in our counting. And then the output, as a final output for our algorithm, will be the summation, which has been calculated by summing all the numbers provided. So let's start the development of our algorithm. So one of the most fundamental things that we are likely to do with a computer is to add a set of n numbers. So when confronted with this problem in the absence of computer, we simply write the numbers down one under the other and start adding up right hand column. So if you see the summation, it is just we in general, like we do the addition, like we put the numbers one another below. Numbers can be anything, it is not a 3 digit, it can be any digit. And then we start the summation from right side, like 4 plus 1 plus 2, it comes out to be 7, then 6 plus 6 plus 2, then there will be 1, and the addition, and so on. So that is a generalized manual problem we can solve when the n numbers are given. Now we have to think from computer point of view how we can have the algorithm on that. So let us see how in computer, or say a simple calculator, the addition happens. So arithmetic unit is there, that is called AU also. So in designing the computer algorithm to perform this task, we must take somewhat different approach, because the AU can take only two numbers at a time as an basic AU. Then there are advanced also. So the computer has built-in device which accept two numbers to be added. Okay, and then performs the addition and returns the sum of two numbers. So if you see here how the things happen, you can talk about how the addition happens. Okay, so here the first number A and second number B will be taken, and then its addition will come up, and the output will be sum of two numbers, A plus B. So the our primary concern is the mechanism for the addition process. So how this addition process we can utilize for our purpose. We will concentrate first on this aspect before looking for overall design, because that is the starting point we have from our computer or the calculator. So on that basis, we have to start with the thinking how we can add at least 2, 3 or 4 numbers, and then we can think of how we can add the n numbers. So to instruct the arithmetic unit to add a set of numbers is to write an expression that specifies the addition we wish to perform. So looking at our previous example where we were adding three elements, we can think here as S is equal to 124 plus 261 plus 562. So that is through expression we are adding. The assignment operator does the evaluation of expression and put the result in memory object specified as variable S. So from computer point of view, we have to store that into a variable. So the given expression can add only given three numbers, which you can see here. And if we want to add new numbers, we need to change the expression as follows, as S is equal to X plus Y plus Z, where all of these four are variables, out of which X, Y, Z should be known beforehand, then only the addition will happen. That means should be passed some values here in x and y and z, and then we will calculate s as the total. S is equal to x plus y plus z will perform the perfect addition, where x, y, z will be our variables having the values which has to be added. Okay. So now how this B expression which we have created can be generalized. So the expression B adds any three numbers which we can see, provided they have been previously as values of variable x, y and z. As I told, the values in x and y and z should be passed. So the given expression B is more general than the expression A, but still has a serious deficiency. What can be deficiency? It can only add only three numbers. That means that is its limitation. We cannot have more than that or even less than that. I have to remove that Z part there. So the fundamental goal of algorithm development is its generality, so that it can add n numbers together, because that is our target we have to achieve. So we need to utilize some of the computer based facts. So what are the best facts about the computer or the algorithm? Are the repetitiveness, the iterative one. So how I can do something repeatedly, then I can achieve my result. Use of arithmetic unit, obviously we need that for the addition, and two numbers at a time. Okay, so that is the things we have to utilize for writing now our generalized equation or generalized formula. So one way to perform this is to add first two numbers, say a1 and a2 only. Suppose we have n, a1, a2 up to an. I will add first two numbers only as a1 plus a2, whose sum sorry, whose sum I am keeping in S. Okay, so S contains the addition of A1 and A2. So we can proceed by adding A3 into S itself again from the C above, and then I can write this because S is the sum of these two things. So if I replace this S with the equation C, it will become S is equal to A1 plus A2 plus A3, which is also correct if I have three numbers. And this can be repeated till the all n numbers are given below. So this procedure which we have thought of having the one by one number addition can be continued, and you can see S is equal to A4, S is equal to A5 up to S plus A1. So that will make the final summation with the addition of all the one old numbers one by one. And that is the way of showing how our algorithm should proceed. So from the step D onwards, we are repeating the same process over and over. The only difference is that the values of A, that is the A1, A2, A3 and S change with each step, and that is obvious. So the general ith step we have is S is equal to S plus AI plus 1, because up to AI the summation is already in S. Now the additional one is adding. So this general step can be placed in a loop to iteratively generate the sum of n numbers, and that is the way we are going to proceed when we write our algorithm. So the algorithm we want to develop for summing n number must therefore work correctly for the sum of 0, because that was the problem statement. We have said it should be n 0 and greater than that. So the problem should work with the 0 elements pass also. Always think of writing a generalized equation, because that is the way your equation will be good and can be useful. So for our case, the sum of 0, that is when n is equal to 0, and the sum of one number, that is only one number is passed, still my summation is that number actually. So this means if we replace this I plus 1 in the expression E, which we are looking at, by I itself, so we substitute I is equal to 1, we get S is equal plus A1 only. So basically, instead of I plus 1, we will have the same symbol A1 there, and then the addition will happen, and then this will work for everything, but not for n is equal to 0 currently or n is equal to 1, because these are the two steps we cannot have here, because what will be the S value then if n is 0 or n is equal to 1? So to do that, we have to have some assumption, and what is that? So the step F, which we have just seen, will be a correct provided S is 0 before this step is executed, and that is the generalized thing or the generalized assignment we have to follow. That is called the pre-development algorithm, where you have to keep some variable with some values, and then only you can proceed. So it follows that all the sums of n greater than or equal to 1 can be generated iteratively. The instance where n is equal to 0 is a special case which cannot be generated iteratively, because that is the starting point, and we are considering if n is 0, our algorithm still works because we start with s is equal to 0. So the sum of zero numbers is 0, and so we can generate the first sum directly by the assignment s is equal to 0. So that is the initialization part we have to do to start our algorithm. So basically the core algorithm which we have thought of is what summing of n numbers. Therefore it involves a special step followed by the step of n iterative step. So it will be compute the sum as s is equal to 0 as a special case. So we have to think on that line, and then build each of n remaining sums from its predecessor by its iterative process. So by predecessor, one by one we add and we generate the output, and then write out the sum of n numbers, because that is the final output we want. So these are the steps we have to follow to contain or to have the output. So let's develop the algorithm and then actually run it. So initialize the array list with n number. So for here also we are considering we have a list or an array with the numbers available. It can be generated randomly also, it can be done with other ways, but we have it already. Initialize the sum for zero numbers. Then we initialize the sum for zero numbers because that is the starting point. And then while there are still numbers to be processed repeatedly, do read the next number from the array or the list and compute the current sum by adding the current number to the most recent sum. And you have to continue this process until the array is exhausted, list is completed, or the number of inputs which you are taking are over. And then write out the sum of n numbers as an output. So that is the algorithm development we have thought of, and let's move to have the code on that. So again, we will write the code from the same point of view as last time we have done. So let's have the first creation of our list with some numbers. Okay, so last time also we have done this. So I have the code here where I have the numbers as the list name, which contains in square brackets some random numbers. We can have 3, 4, 5, anything. So if I just execute it, it is a simple case. As we know, it initialize it and it will print it. So just in a two step, I have the list with the numbers with the index. Okay, so that was the first part, easiest part, which we have done last time also in our counting mechanism. Let's see how I can loop it through. So that part was also with the for loop. So simple for loop you write, and one by one you go inside, you have the output. So let me have this one. I am taking the numbers, the same thing, but now I am doing what? I am printing them one by one by just using the for loop. So if I go for the visualization of the code, numbers is done, and now I am on for loop. In for loop, I am using one variable index of number, which will index one by one number of data type integer, and it will be printed just for our case to loop through, because when we develop our algorithm, we have to make sure we are going one by one into each element. Then we can thought of summation and all that process, not at the beginning. So if I start my initialization, this indicator number will get the value one by one from the list. And if I do next, 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 the loop will continue and the numbers will start appearing with this index. Okay, so if I continue this, the process goes up to 33, and once 33 is printed, my loop is over and I am outside of my code. So the process is simple. We have taken the numbers one by one from inside the list. Now let us see how we can add the things which we want. So basically the code which we will need to do the summation is here, and you have to closely look to this code so that you get the idea what the things are happening and how I can utilize that thing step by step. So let me execute the code now. Now the first procedure is the same. The next step is the new thing. What is the new thing here? I have added the new variable n underscore sum. So that is the initializing sum s, which we were discussing up till now. I have given a more generalized name n sum, which is initialized to 0. So suppose this list is empty, still our code will run, the loop will not run, and the sum will be printed as 0. Even if it is only one element, still it will work. Many elements, still it will work. So all the things will be done clearly. So numbers is here, then sum is 0, and now my loop starts. So when I go into the loop, I have the first element here as 26. Now here you look closely, and sum, which is 0, indicator number is 26, and what I am doing here, n sum plus indicator number, so 0 plus 26. So the output will be 26, which will put here, and I will go back because the for loop continues. So if I put next, what happens? Now I have the first number in n sum, and indicator is still 26 because this line is not till run now. So let's run that. Now in this position, n sum is 26 because old values, and now new number is 50. So this addition will proceed, but again it will put where? In the same position here, n sum. So that is also a best thing. So let me do the next. So you will see the summation has happened 76. So n sum at each step is calculating the summation one by one. And then we are proceeding. I haven't put this print inside. If I put it inside, what will happen? It will print this sum one by one if I want, if that is the case. But currently our case is I want the summation. So I will go next. So again I will have the next value and the addition will happen. And this process will continue up till what? Up till 33. So what we are doing the same thing as we have explained. S is equal to S plus AI, where AI is one by one elements which is coming into picture and adding it to the n sum up till what point? Up till the list is exhausted. At this place we are at the last point 33, which is here, and 491 is the sum up till 26 to 88. That is the summation we have achieved up till now. And once I do that, this is the final sum we will have. Now here the list is exhausted, so I am outside the loop, and hence my final requirement is printing that. So I have printed that. So the final output is 524. Now this shows that our code is working very well for all the values which is provided. Now you should always check some test cases where it works from other condition, like if there are only one element. So what happens? Let us see that. So whenever you write your code, do remember to check for all the if and else, because that is also the requirement. Okay, so if I have only one element and if I run this, so let me run this. So I have only one input in that. So the list is with only one element, sum is 0, and when I bring that sum first element, 26 will come out and it will be added to 26. The list is exhausted, so I am outside, and since I am outside, I will print the value 26. So you can see our algorithm is very well. It works with n is equal to 1. Okay, and it will work for n is equal to 0 obviously, because sum is 0 and the list is empty. So if I want to create such kind of empty list, I can do that. So the way it is just the Python you have to understand. So I can say list is empty by just putting the this thing. So now n is 0 in this case. Okay, now if I run my code again, so you will see the list is empty, which is fine. So nothing is there. You can see the list is empty list. The summation is 0. So obviously because no element, so the sum will come out to be 0. No for loop will run. I will directly drop down to sum. And if I print, the summation is 0. So for each test cases, n is equal to 0, n is equal to 1, n is greater than or equal to 1, my algorithm works fine. And that is the way you have to develop the algorithm, and yes, you have to test it, because what happens for some of the inputs which we pass, we always think our algorithm is running fine, and that is true, but in actual for some other input, and that's why the industry has the tester field. Okay, so many testers are there in the industry who test your code rigorously to come up with the faults, and that is required. You cannot have the software or anything which runs as it is. So this thing also you have to go through so that you will have a proper output. So that was the summation algorithm. Let us see some of the points remaining in that which we have to see. So this all things we have already come up with. Now once we design our code, what are the notes we should make sure? So the sum to sum n numbers, n minus 1 addition need to be performed. So this is important. So in actual, when n numbers are there, we have to perform n minus 1 addition. Like 3 numbers, it will be 2 plus signs. 4 numbers, 3 plus sign. But in our case, in present algorithm has used n addition instead. Why? Because we have s is equal to 0, where we add 1 by 1 element. So one addition we are increasing, but at cost of what? A simpler and cleaner implementation. So that thing you can consider. Second is consideration of the problem at this lowest limit, that is n is equal to 0, leads to a mechanism that can be extended to larger values of n by simple repetition. So now no limitation is there. You can list have 100 elements, still our algorithm will work properly. Rather than the program that we have, more important will be a function that returns the sum of an array of n number. So in general, program is not that of important. Functions are, where you have the function say sum and you pass the list as an output, that summation will come up. The code remains the same which we have written. The functionality of writing a function will change, but you can think of that also as we will proceed in our programming Puran. We will have more and more examples on that also. Simple applications which we can talk about is average calculations, variance, and least squares calculations, where all of the thing summation comes into the picture. Useful mechanism in all types of summation and algorithm. So basically it is useful for all kinds of applications where summation is there. So this is the way we can have the development of summation, starting from the basic thing of manual addition to an algorithm which does the addition automatically. Hope you enjoy this video. Do have your own hands, so you can have the own hands dirty with this kind of code, because you have to try multiple things to come up with this. Okay, so thanks for joining this whole video. Do subscribe our channel so that you will have more and more videos in our session or on our channel, which is Programming Puran with Python. Thank you and namaste.